Now we will see the refraction of a plane wave by using Huygens principle. This is the medium one, nothing but the air. And from this medium 1, light is coming towards this medium 2. I am drawing this one. This is medium 2. This is medium 2. So the velocity of this light wave is, let us say, v1 in the medium 1. Velocity of light wave in the medium 2 is v2. So like this it is formed, and from the, with respect to the normal, it is bending towards the normal when it is traveling from medium 1 to medium 2. So this is the incident wave front. So with respect to this incident wave front, I extended this wave front line, draw another parallel line, which is BC. This PC is parallel to the incident wave, and this is refracted, and from this refracted one I try to join with the point of C, which is on the surface of the medium. Now we can see ABC one triangle and AEC is another triangle. So this is a localized plane wave. So from this explanation, what is sin I? This is I, opposite side BC by AC, opposite by hypotenuse. What is sin R? AE by AC. But what is BC and AE? BC is the incident wavefront which is parallel to the incident wave. What is the distance? BC is nothing but the distance traveled from B to C. So for distance is equal to, we can write V into tau. So we can write distance, velocity is equal to distance by time. So distance is equal to V into time. So in this one, let us take the time is tau. Here also let us take the time is tau. So BC is equal to V1 tau and AC is common, where AE is equal to, let us say, in this medium the speed is V2, therefore we can write V2 tau by AC. So from this one, sin I by sin R is equal to V1 tau by AC whole divided by sin R, means V2 tau by AC. That V2 tau by AC will goes up and AC by V2 tau. Tau get cancelled, AC get cancelled. We will get V1 by V2 is equal to sin I by sin R. But see, this is a glass medium. Let us take the medium 2 as glass or any denser medium. This is a rarer medium. When compared to the rarer medium, the speed of light in denser medium will be less. That means what we can write, V2 is less than V1. If V2 is less than V1, what we can understand, V1 is great. V2 is less than V1 means V1 by V2 is greater than 1, then sin I is greater than sin R. That is a very, very important one. But this phenomena is simply a contradiction to the Newton's corpuscular theory. What is Newton's corpuscular theory? In that theory, light is changing its velocity when it is changing from one point to another point or one medium to another medium. So these predictions are going to be wrong. So that's why we are seeing the modulated method. And we know that refractive index of the first medium N1 is equal to C by V1, where C is speed of light in air or vacuum, in medium 1 by speed of light in medium 2. Such like that N2 is also C by V2. From this one, what is N1 by N2? C by V1 into V2 by C. C get cancelled. V2 by V1 is equal to N1 by N2. Relative refractive index N1 by N2 is equal to V2 by V1. But we know that this BC and AE are the distance travelled by the incident light wave and reflected light wave, refracted light wave, nothing but the wavelength. So we can write lambda 1 by lambda 2 is equal to BC by AE. Let us write this one is lambda 1, AE is lambda 2. But lambda 1 is V1 tau, lambda 2 is V2 tau, and we are going to substitute that. Lambda 1 by lambda 2 is equal to BC by AE, that is nothing but V1 tau by V2 tau is equal to lambda 1 by lambda 2. So what we can say is lambda 1 by lambda 2 is equal to BC by AE, but what is BC? V1 tau, AE V2 tau. So tau get cancelled. Therefore lambda 1 by lambda 2 is equal to V1 by V2. From this we can write V is proportional to lambda. And one more thing, V1 by lambda 1 is equal to V2 by lambda 2. This V1 by lambda 1 or V2 by lambda 2, or if you remove the proportionality constant, you will get frequency. Therefore, nu1 is equal to nu2. This nu1 is equal to nu2 is nothing but frequency of the incident wave is equal to the frequency of the refracted wave, because wavelength is going to change when the medium changes, and one more thing, speed of wave is also going to change when the medium changes. The change between that V and lambda is in a proportionality order. That's why frequency won't change. That's why the V by lambda ratio is always constant. That constant is called frequency of light. This is light wave traveling from rarer medium to denser medium. If suppose light ray traveled from denser medium to rarer medium, what is the calculation? We will see now. So in this case, yes, this is the incident wavefront, and this is the denser medium. This case was exactly opposite in the direction of the first one. In the first one, rarer to denser is the propagation of light. Here it is denser medium, means denser to rarer wave is propagating. So in this case, what we can understand is the light wave bends away from the normal. So this point is very, very important. So for this purpose, just try to change the angle slightly. So this is the normal, this is angle of incidence, this is angle of refraction, and these two are joined like this. So this is angle of incidence, so this is angle of refraction. Same, the values are BC, EC, and point is A. The light is refracted from this one. So here it is V1 tau, here it is V2 tau. What is Snell's law of refraction in this case? So according to the Snell's law of refraction, we know that N1 sin I is equal to N2 sin R. So from this, sin I by sin R is equal to N2 by N1. If I is equal to IC, what is this IC? Critical angle. if angle of incidence is at critical angle, then angle of refraction will be 90 degrees. So correspondingly, R will become 90 degrees. Therefore, sin R is equal to 1. So, sin IC is equal to N2 by N1. Therefore, IC is equal to sin inverse N2 by N1. For angle of incidence which are greater than critical angle, if the angle of incidence is greater than critical angle, then there will be no refraction takes place and light will go to the multiple reflections within the medium. This is called total internal reflection. So this is the one of the important one we can discuss. So if I greater than IC, which causes to total internal reflection. So from refraction phenomena, we are proving the reflection which is internally and totally. So that's why the objects will appear brighter at twinkling because of this phenomena when the cases are satisfied with these rules. Next one, reflection of a plane wave. Let us take a plane surface. This is the incident wave and draw the normal, and this is the reflected wave. I, with the same angle of reflection, we can draw R. Therefore, this is point A, this is E. So in this point, we are going to get the wavefront respiration. That's why this is the incident plane wave with some angle of incidence. And is reflected back and touches this one. And from this, we are again drawing this one. This is I and R, and here also it is I, it is R. So what we can understand in this case is, this is the incident wave, and to understand this phenomenon we draw this wavefront. This is incident wavefront. So this is the reflected wavefront. So we can say that AE is equal to BC because of the same identical in nature and wavefront phenomenon, and we can write this one as V tau. This AE is a reflected wave, BC is the incident wave. So therefore, reflected wavefront is equal to incident wavefront. This is very, very important. That's why V1 tau is equal to V2 tau. Correspondingly, we can call it as V tau. That means reflection and incident takes place in the same medium. That's why speed of light is not going to change. But in case of refraction, it changes. The speed of light is not changing. That's why we can say AE is equal to BC is equal to V tau. So it is valid for plane mirrors. But the same light pattern, if it is traveling through the curved mirrors and lenses, and how will it act and what are the rules to propagate, we will see now. So this is the very, very important phenomenon in a plane wave propagation of light in case of reflection.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.